So students, let us do the next exercise 3.2. In this, the first question says, form the pair of linear equations in the following problems and find their solutions graphically. The first question is, 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. Look here, we have number of girls to be x and boys to be y. So first condition was x plus y is equal to 10. Very simple equation. For when I take x is equal to 4, obviously y is equal to 6, and when we take number of girls as 6, the boys have to be 4, and if I take number of girls as 5, obviously boys also will be equal to 5. So these are the points for the first equation. Likewise, for the second condition, x is equal to y plus 4 because girls are 4 more than the boys. So x is equal to y plus 4 or x minus y is equal to 4. If I put the values of x, if I take x as 8, I get y is equal to 4. Likewise, on taking x is equal to 6, I get the value of y as 2. Likewise, for when x is equal to 7, y is equal to 3. So both the lines are meeting at which point? 7, 3. Because if I take here 7, here the value of y will be 3. So this is a common solution for the pair of equations. So the solution is 7, 3, x is equal to 7 and y is equal to 3. Number of girls is 7 and number of boys is 3. Let us see the graph. Can you see these two lines we have plotted? This is for x plus y is equal to 10. The points 0, 10, 3, 7, 4, 6, 5, 5, 6, 4 we have plotted, and these all points are satisfying the given equation. Likewise, the other line x minus y is equal to 4 is represented in the graph in this way: 4, 0, 5, 1, 6, 2, 8, 4, and obviously the common solution is shown here 7, 3. That is, number of girls is 7 and number of boys is 3. I hope you have understood. Let us look into the next question. 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. Find the cost of one pencil and that of one pen. So let us take, let the cost of one pencil be rupees x and cost of one pen be rupees y. So according to question, I get 5x plus 7y is equal to 50. This is our first equation. Second condition is 7 pencils. So I get 7x plus 5 pens. So 5 into y is equal to 46. These are the two equations. Now if I solve these equations, see, from first equation I get 7y is equal to 50 minus 5x. So y is equal to 50 minus 5x upon 7. Now to find out the various values, see here, I am going to teach you a very simple method of finding the values x and y. Let us think of a value which gives me a multiple of 7. Just one value we have to think of so that we can get a real number. Let us see here. If I take x is equal to 3, 50 minus 15, it gives me 35. So 35 upon 7 is 5. Point is 3, 5. After we get the value, one value, there is a trick here. Just look at this number 3. 3 plus 7 denominator, it gives me 10. 7 plus 3 is 10. So let me check for 10. What is 50 minus 50? 0. So easy to calculate the point. Likewise, what is 7 plus 10? It is 17. So what is 17? 5s are 85 minus 50, it gives me minus 35. So what is minus 35 by 7? Minus 5. So this way we can calculate the points. Let us look into the second equation. We have calculated the values here in the same way. We have for second condition 7x plus 5y is equal to 46. So we get 5y is equal to 46 minus 7x, that gives me 46 minus 7x upon 5. Now if I take the value of x as 3, look here, I get y is equal to 46 minus 21 upon 5, that is nothing but 25 upon 5, that gives me 5. One value I have taken as 5. Now next value, see, it is easy to generate. 3 plus 5 is 8. So y is equal to 46 minus 8 sevens are 56 upon 5. That gives me minus 10 upon 5, that is minus 2. Now once we can add and next we can subtract also. That means 5 plus 3, that was 8. Likewise, we have 8, we have taken the value as minus 2 here, because 5 minus 3 is 2. So if I take minus 2, what do I get? Y is equal to 46 plus 14 upon 5, that is 60 upon 5, and the point is 12. I hope it is clear. Now let us see the graph of these equations. See here we have the points. This is the graph of the equation. 5x plus 7y is equal to 50. The points, the lines which are meeting the common point is 3, 5, that is the unique solution of these two equations. The other equation was 7x plus 5y is equal to 46. The points you can see which we calculated are shown here. If we plot, they meet at a common point, and that is the solution of this equations. So students, before we go into question number 2, let us have an introduction about the conditions which are required for solving the linear equations in two variables. What was the general form? We had a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So we have three different cases. For unique solution, the condition is a1 upon a2, that is the coefficients of x ratio should not be equal to b1 upon b2. a1 upon a2 should not be equal to b1 upon b2. In this case, we will have unique solution always. And next, let us take up for no solution. For no solution, we will take a1 upon a2 is equal to b1 upon b2, and that will not be equal to c1 upon c2. Is it clear? For unique solution, a1 upon a2 will not be equal to b1 upon b2. For no solution, a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Then for infinitely many solutions, we have a1 upon a2 is equal to B1 upon B2 and that is equal to C1 upon C2. These are the three different conditions we have in three different cases. In this case, we call the system as consistent system because it has a solution. Here for no solution, the system will be called as inconsistent system. For infinitely many solutions again, we call it as system is consistent. So, now let us summarize. We can summarize the behavior of lines representing a pair of linear equations in two variables and the existence of solutions as follows. The lines may intersect in a single point. In this case, the pair of linear equations has a unique solution, just now we have discussed, that is said to be consistent pair of equations. For the lines may be parallel. In this case, the equations have no solution and we call it as inconsistent pair of equations. In the third case, the lines may be coincident. In this case, the equation have infinitely many solutions and we call it as dependent system and consistent pair of equations. Let us consider the pair of linear equations formed and note down what kind of pair they are geometrically. Very interesting. Let us see. We have three different pairs of linear equations here. X minus 2y is equal to 0 and 3x plus 4y minus 20 is equal to 0. The lines intersect in this case because can you see 1 upon 3 will not be equal to minus 2 upon 4. By the sight of the linear equations, we can just judge whether they will have unique solution or infinitely many solutions or no solution. In the second case, 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0, the lines will coincide. Just observe the equations. Here we can find that second equation is nothing but I have multiplied the complete equation by 2. So, I get 2 upon 4 is equal to 3 upon 6 is equal to 9 upon 18. That is 1 upon 2 is equal to 1 upon 2 is equal to 1 upon 2 and therefore, we have infinitely many solutions and the system is dependent. Look here in the third case, x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Here the lines are parallel. Can you see? We have a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Look here, 1 upon 2 is equal to 2 upon 4, but that is not equal to 4 upon 12. Now, let us now write down and compare the values of a1 upon a2, b1 upon b2 and c1 upon c2 in all the three pairs of equations. Here a1, b1, c1 and a2, b2, c2, they denote the coefficients of equations. Let us see in the tabular column here, we have pair of lines in all the three cases and these were the ratios of the coefficients of x 1 upon 3, here you have 2 upon 4 and 1 upon 2. Likewise, the coefficients of y here minus 2 upon 4 and 3 upon 6 and 2 upon 4. Same way we have taken constants 0 upon minus 20, minus 9 upon minus 18 and minus 4 upon minus 12. And when we compare the ratios, you will find in the first case a1 upon a2 is not equal to b1 upon b2 and the lines are intersecting and exactly one solution we get in that case and we say that it has pair of equations have unique solution. In the second case, we find that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2 and we have coincident lines and that shows it has infinitely many solutions. In the third case, we find that a1 upon a2 is equal to b1 upon b2 but that is not equal to c1 upon c2 and therefore the lines are parallel and the system has no solution. I hope the things are clear. So students, let us make use of the three conditions we have just now learnt, and we will apply them here. On comparing these equations with a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, we get a1 as 3, b2 as 2 and c1 as minus 5. Can you see from the equation? And a2 is 2, b2 is minus 3 and c2 is minus 7. Here a1 upon a2 is 3 upon 2, b1 upon b2 is 2 upon minus 3 and c1 upon c2 is minus 5 upon minus 7, that is 5 upon 7. Can you see here? 3 upon 2 is never equal to 2 upon minus 3. That means a1 upon a2 is not equal to b1 upon b2. So, the given equations intersect each other at one point and they have only one possible solution. The equations are consistent. That means it has a unique solution. Let us look into the next part. 2x minus 3y is equal to 8 and 4x minus 6y is equal to 9. On comparing these equations with the general equations, we have a1 is equal to 2, b1 is equal to minus 3, c1 is equal to minus 8 and a2 is equal to 4, b2 is equal to minus 6 and c2 is equal to minus 9. We find here that a1 upon a2 is 2 upon 4, which can be reduced as 1 upon 2, b1 upon b2 is 3 upon 6, that is again 1 upon 2 and c1 upon c2 of course is 8 upon 9. That means a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. So, the given equations are parallel to each other and they have no possible solution. So, the equations are said to be inconsistent. Let us see the next one. 3 by 2x plus 5 upon 3y is equal to 7, 9x minus 10y is equal to 14. On comparing these equations with the general equations, we find that what is a1? It is 3 upon 2, b1 is 5 upon 3, c1 is minus 7 and a2 is 9, b2 is minus 10 and c2 is 14. We can see here a1 upon a2 is equal to 3 upon 2 into 9, that is 1 upon 6, b1 upon b2 is equal to 5 upon 3 into minus 10, that is minus 1 upon 6 and c1 c2 as minus 7 upon 14, that is equal to minus 1 upon 2. We can see here a1 upon a2 is not equal to b1 upon b2. So, the equations are intersecting each other at one point and they have only one possible solution. So, the system of equations are said to be consistent in this case. Let us look into the next part. 5x minus 3y is equal to 11, minus 10x plus 6y is equal to minus 22. On comparing these equations with the general equations, we get a1 is equal to 5, b1 is equal to minus 3, c1 is equal to 11, a2 is equal to minus 10, b2 is equal to 6 and c2 is equal to minus 22. So, when we take the ratios a1 upon a2, we get 5 upon minus 10, that is equal to minus 1 upon 2, b1 upon b2 is equal to minus 3 upon 6, that is equal to minus 1 upon 2 and c1 upon c2 is again 11 upon minus 22, that is equal to minus 1 upon 2. Can you see here that we have minus 1 upon 2 in all the three ratios? a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So, the equations are coincident lines and they have infinite number of possible solutions. Hence, the equations are said to be consistent. Let us look into the next part. 4 upon 3x plus 2y is equal to 8 and 2x plus 3y is equal to 12. On comparing these equations with the general equations, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, we get a1 as 4 upon 3, b1 as 2, c1 as 8, a2 is 2, b2 is 3 and c2 is 12. When we take the ratios, what do we observe? a1 upon a2 is equal to 4 upon 3 into 2, that is equal to 2 upon 3, b1 upon b2 is 2 upon 3 and c1 upon c2 is 8 upon 12, that is again reduced to 2 upon 3. That means a1 upon a2 is equal to b1 upon b2, again equal to c1 upon c2. So, the equations are again coincident lines here, and they have infinite number of possible solutions, hence the equations are said to be consistent. So students, I hope you have understood the concept of these pair of equations. Today we did it in a graphical way, and also we learned the three conditions when the pair of equations are having unique solution, no solution, or dependent system, that is they have infinitely many solutions. Thank you.